In the late 19th century, a glowing beam inside a vacuum tube changed physics. That beam was called a cathode ray. This video explains the cathode ray experiment, the experiment that proved the electron exists. A glass discharge tube is fitted with two metal electrodes. The electrode connected to the negative terminal is the cathode. The positive electrode is the anode. Air is pumped out until the pressure is very low, only a few millimeters of mercury. When a high potential difference is applied, a stream appears to leave the cathode and travel towards the anode. These streams are cathode rays. At ordinary pressure, the gas conducts poorly, and you do not get a sharp beam. At very low pressure, charged particles can travel long distances with few collisions. That is why the tube must be evacuated. If a solid object is placed in the path, a sharp shadow appears on the opposite fluorescent wall. Sharp shadows mean cathode rays travel in straight lines when no field is present. They also produce fluorescence where they strike the glass. A light paddle wheel placed in the path begins to rotate. That shows cathode rays carry momentum. They behave like a stream of particles, not like ordinary light. The spot they hit also becomes hot, so they carry energy as well. Now pass the beam between two plates. When an electric field is switched on, the rays bend towards the positive plate. Particles attracted to the positive plate must themselves be negatively charged. This is the key JEE observation. Cathode rays are negatively charged. A magnetic field also deflects the beam. The direction matches the force on a negative charge. Light is not deflected by electric or magnetic fields in this way, so cathode rays cannot be electromagnetic waves. They are charged particles. Change the gas inside the tube or change the metal of the cathode. The nature of the rays remains the same. These particles are not fragments of one particular atom. They are a common constituent of all matter. J. Thomson concluded that cathode rays are streams of identical, negatively charged particles, much lighter than the lightest atom. He called them electrons. The cathode ray experiment is the discovery of the first subatomic particle, and the first clear proof that the atom is not indivisible. If a question asks for the nature of cathode rays, write material particles, negatively charged, identical for all